Showing off for the ladies, a salmon leaps out of the water for 1.6 seconds. How fast was he going and how high up did he get, yo? So first I would just want to say that most of my viewers are not in the United States. What you need to know about the United States is that we end our questions typically with yo, so that you know that the question is over and it's time to begin answering. This salmon is in the air for 1.6 seconds. We'll draw a little sketch. This is what salmon look like. I am not a fisherman, but I am an artist, an artiste perhaps. So there's water down here, that's why it's blue. The salmon ought not to be blue. It'd be great if the salmon were salmon colored. There, now we go. And the salmon goes up, whee, like this. And somebody was timing. They had one of these timers here with 3 buttons on it, you know? And they were like, click, and they got the time to be 1.6 seconds. So the salmon was in the air for a good bit of time, and we need to figure out, whoa, how fast the salmon was going and how high up he got. So I don't really know how fast he was going in this direction, because nobody said anything about it. So I'm gonna assume how fast he was going means in Y direction. We could just say that this salmon leapt straight out and then splashed back in, because the sideways motion is independent and doesn't really affect our problem at all. So in order to do this, we need to examine what's happening to the salmon at one particular moment, right here. At the top, I can say that V in the Y direction is 0. What do you want to do first? How fast was he going, or how high up did he get? I don't really know. When does this happen though? When does this happen at the top? The thing about this is I see a parabola here, and I see this parabola is symmetric. It's interesting that the time it takes to get up to the top is exactly the same as the time it takes to get back down, assuming the salmon's not doing any of this awesome leaping up to meet the ladies kind of thing, you know what I mean? No, the salmon's just in some like level water here. So the salmon is in level water going up and coming back down. So at the top, this happens at T half, or I could call it T top. T top is in fact 1/2 T total. See how I did that there? Top, tote, yeah, great. So that's going to be 0.8 seconds. All right, here's my plan. My plan is to write down that we know the time at which the velocity is 0, and also I'm going to write that V in the Y direction is 0 at the top, and we also know the acceleration in the Y direction, negative 9.81 meters per second square. Now I go to my equations. Lucky for you, I've written the 4 kinematic equations in the Y direction right here. Let's see. I'm gonna refresh my memory. I know time, I know final velocity in the Y direction, and I know acceleration in the Y direction, and I'm gonna try to find out initial velocity. So I want initial and final in my equation, and I want time in my equation, and I want acceleration in my equation. Let's write those down right here. I want the initial, the final, acceleration, and time. Which equation has those in it? Oh, this one right here. So we have to be very careful as we're using the definition of average acceleration. I'll write it down on the next page and we can get to work. It says V in the Y direction is the initial velocity in the Y direction plus how the acceleration in the Y direction has changed the velocity in the Y direction. And I guess I'm going to solve this sucker for the initial velocity in the Y direction, because I already know the final velocity in the Y direction is 0. That was my statement that says the salmon stops up at the top. I'll leave you this picture. At the top, the velocity in the Y direction is 0. So I'm going to plug in my 0, because that gives me a little bit of freedom to do the algebra more simply. 0 equals the initial velocity in the Y direction plus acceleration in the Y direction times time. And I'm going to go through the algebra really quickly, because I don't like to spend a lot of time on algebra. So I'm going to find the initial velocity in the Y direction, and it seems like the initial velocity in the Y direction is simply, well, I'm just going to subtract this from both sides. It's acceleration in the Y direction negative. Ooh, negative. You mean the opposite of the acceleration in the Y direction? Yes, I do, and I'm planning to multiply these suckers, and for the purposes of, well, I forgot my calculator on the other side of the room, I'm going to call baby G approximately 10 meters per second squared, so that we can do this math all entirely in our heads. So what I notice is, and this is nice because if you're on a camping trip and you're watching some salmon jump, you don't want to get your graphing calculator. Now look, I know you do want to get your graphing calculator, but you might have forgotten it or the batteries could be dead. You know, these things can happen. So I'm gonna plug in here -10 meters per second squared. Wait a second, that's what the acceleration in the y direction is, but we've got a minus sign in front of that. So I've got -10 meters per second squared multiplied by the time, and I found that time to be 0.8 seconds. Now, why didn't I use the full time? Oh, I didn't use the full time because I said the velocity final in the y direction was 0. That's only true at half the time, see? At t half, it's at the top, and the velocity in the y direction is 0. So I'm using this key fact here. I have to divide the time by 2 because my battery might die, and that would be embarrassing. No, seriously, I have to divide the time by 2 because it is at exactly halfway through the trip of the salmon that its velocity in the y direction is 0, and we've used that fact right here. So I did the math already while you weren't watching because my battery was dead, and got 8 meters per second. That's the initial velocity in the y direction of this particular salmon, and we'll answer the second question, how high up did he get, yo, during this jump, in the next video. Bye-bye.